Now solution, we have 2 to the x plus this whole guy 2 to the negative x. Remember from your laws of indices, when I have a to the negative m, it's the same as 1 over a to the n. So that guy becomes 1 over 2 to the x equal to 2. All right, so that is it. Now I want to get rid of this fraction. Okay, I want to multiply everybody by 2 to the x so that this guy will go out from here. So if I multiply here by 2 to the x, I'll multiply that by 2 to the x, you understand? Then plus, I'll multiply all these guys here. Let me put it in bracket like this. So I'll multiply everybody here by 2 to the x. So I have 1 over 2 to the x equal to then 2 to the x times 2. And of course, this is the same thing as 2 to the 1, right? Good. Now, the whole idea of doing this is to cancel out these guys. And now 2 to the s and 2 to the s will give us what? From the laws of indices, when they have the same base and they are multiplying, you take one of the base and you add the exponents. It's going to be like x plus x, then plus 1, then equal to the same thing. They have the same base, they are multiplying, add the exponent. It's going to be like 2 into x plus 1. That's the law of indices. We already have videos on indices, so you can go and check our playlist on our channel here. Check the grade 10, you will see questions on indices. So now let's go ahead. We have here to become 2 to the 2x, x plus s is 2x, then plus 1, then equal to this guy is going to be like 2. This is the same thing as, okay, better still, sorry, I don't need to expand this old guys. I think we don't need to do that because we need it. We don't need to add up this whole power. Okay, we don't need to do that. So here it just become 2 into 2x. All right, so don't go ahead to expand this. There's a reason for that. So but this one we can simplify this one. So we have x plus x is 2x and here is 1. So bringing this guy inside, you have minus 2 into 2 to the x equal to 0. I hope this is clear so far. We just brought this guy inside, so it becomes negative when it comes inside. And now the whole idea of doing this is to convert this equation to quadratic equation. So from your laws of indices, if I have a to the mn, I can write these guys as a to the nm. I can interchange this position because multiplication is commutative. What I mean, mn is the same thing as nn. 2 times 3 is the same thing as 3 times 2. So it is commutative. So, and that means I can also write it as a to the n, then all to the m, right? That is making sense that way. So these guys can be written as 2 to the x all to the 2 for what I just explained earlier. And bringing this guy closer, I have minus 2 into 2 to the x, then plus 1 equal to 0. Now, this is looking like a quadratic equation, right? But if it's not clear, if it's not really looking like a quadratic equation to you, I'm going to say let p be equal to 2 to the x. So that this guy now becomes, this whole guy becomes p. And this guy has a square, so it's going to be like p squared minus 2. And this 2 to the x here is p. So there becomes p here, then plus 1 equal to 0. Now, this is a quadratic equation. And you can solve this quadratic equation by factorization. Now, you multiply the coefficient of p here, which is 1, with this constant. 1 times 1 will give us 1. So we're looking for two numbers such that when you multiply them together, you will get a 1. That's this one. And when you add them together, you get this minus 2. When you add the same two numbers together, you get minus 2. The numbers are just 1, minus 1, and minus 1. Minus 1 times minus 1 will give me a positive 1, and minus 1 plus minus 1 will give me minus 2. So here becomes p squared minus 1p, then minus 1p. So those guys, this minus 1 and minus 1, we are representing them in the form of p, just like we have minus 1p will give me minus 2p. So instead of writing minus 2p now, I'm going to write them as minus 1p minus 1p. That's why I'm writing these guys in this form. Then we have here plus 1 equal to 0. The next thing you want to do is to group them. You group these guys like this. And now what is common here? What is common here is p. So when you factor out p, if p divides p squared, you'll be having p, you understand? And if p divide this minus 1p, you get just 1. As if to say p times p is p squared, and p times minus 1 is minus 1p. Then leave a space here. Whatever you have here, just come over here and paste it. So p minus 1 equal to 0. Then you come out to this space. What will you multiply with this p here to get minus 1p? Of course, it's going to be minus 1, because minus 1 times p will give me minus 1p. And minus 1 times minus 1 will give me positive 1. The reason why I say you should leave a space and paste what you have here, right here, is because these two factors must be the same. And why? Because as they are the same now, we convert it to be one factor. So you have p minus 1. And this guy is hanging outside, p minus 1 will come inside. I mean, this guy is right here, is the next factor, all equal to 0. Now, it seems they are both twice, so we can equate each of them to 0. P minus 1 is equal to 0, or the other p minus 1 is equal to 0. So here we have p equal to 1 and p equal to 1. So definitely, p is equal to 1 twice. But remember, this is not our final answer. Remember, our question was given to us in form of x, and we make an initial substitution. So you're going to recall that p is equal to 2x. So now, 1 is equal, so this p now is 1, so 1 is equal to 2x, right? And this one, 1 is the same as 2 to the power 0, right? So 2 to the power 0 is 1, so I want to write it as 1, so 2 to the power 0 is equal to 2 to the power x. The reason why I'm using 2 is because I have 2 here. I want the base to be the same. If I had 3 here, I would have used 3 to the power 0. I want the base to be the same, because when the base are the same, we can cancel out the base and equate the exponent. So x is equal to 0. Wow. So all of this problem, we got 0 for x. Wow, that's interesting. So thank you very much. Let us go